So this talk is called ClojureScript Lisp's Revenge. So raise your hand if you've ever used a Lisp. This is great. So this is good. I have a good audience. Okay. So John McCarthy invented Lisp in 1957 to solve this really crazy problem called artificial intelligence. I believe he actually coined the term. What's great about he was sort of surveying the programming languages landscape in 1957, and he realized that there was nothing suitable for doing artificial intelligence. So he decided to invent Lisp. At the same time, he invented dynamic programming languages, interpreters, sensible metaprogramming, functional programming, programming with recursive functions, garbage collection, right? All at the same time. That's a pretty incredible moment for computer science. So Lisp still to this day occupies this very interesting space in that on the power spectrum, there's a lot of expressive power. At the same time, the model is extremely simple. Alan Kay, the sort of grandfather of modern OOP, often referred to this half page of the Lisp 1.5 user's manual as the Maxwell's equations of software. So at the bottom of the page is defined eval and apply, and that's basically all you need to get a full-blown Lisp system. So, fast forward to 1967, one of the greatest films ever made by Stanley Kubrick. This is a still from Space Odyssey, 2001: A Space Odyssey, featuring an artificially intelligent computer, the HAL 9000, very famous film character. I think in the 60s, people were pretty bullish, right? People were like hearing about artificial intelligence and things that were happening at the various universities on this topic, and they were like, oh, by 2001, we'll have something like this. Fast forward to 2013, HAL 9000 is still nowhere to be seen, and probably that's for the best. So what's interesting is that, you sort of think, well, we're not building AI, and that seems really hard, but we are actually building really complicated systems, right? This is Web Rebels. I don't think anybody would have imagined in 1957 that most programmers are involved in the business of distributed computing. Like, you don't think of yourself as being a distributed computer scientist, but essentially we all are, whether you're working on the back end or the front end. And so what's fascinating is most of the things that we use in our stack aren't designed for distributed computing, right? Brendan Eich didn't invent JavaScript and say, oh, we need a language for distributed computing. Guido van Rossum didn't create Python and say, oh, we need to do distributed computing, right? In fact, those languages are actually not so great for distributed computing. In fact, because they're not suited for it, a lot of our systems have a lot of what's called accidental complexity. This is one of Rich Hickey's favorite phrases. I don't know if you've ever seen him talk, and I'm not going to try to summarize the types of things he talks about. I thoroughly recommend looking up his talks. So, Rich was a C++, C# Java programmer in a past life, sort of specializing in highly concurrent systems. And so he did this for about 20 years and realized that he was sick of it, that it was too hard, that it was too difficult. And in fact, he almost said he was about to give up and stop programming because it really his joy in doing that type of programming in traditional programming languages was gone. So he fortunately didn't decide to quit, and he created a Lisp for the JVM, the Java Virtual Machine, Clojure. And it's seen some success. It's very much oriented around doing multi-core programming and concurrent programming. Twitter uses it, Citibank uses it, Akamai uses it, UBS uses it, Prismatic, which maybe some of you have heard of on Twitter. So it's doing pretty well for the niche that it fits. But the JVM doesn't run everywhere. I mean, back in the early days when Sun talked about Java, there was this sort of fantasy that, oh, Java will run on the server, it'll run on the client, it's going to really solve these internet problems. Of course, that doesn't pan out. I mean, whenever you see like Java Web Start or like a Java applet load up, you just sort of close that web page, right? So JavaScript is really the language of clients, and that's increasingly becoming the case. And so Rich said, we have this kind of like, we sort of encapsulated this philosophy of trying to simplify complexity. That's sort of Clojure's real philosophy, is like actually trying to eliminate complexity. And he decided, oh, what if we target JavaScript? We can reach more people. We can allow our developers to reach more targets. And maybe we can bring some of that simplicity to the types of software you would write normally with JavaScript. I actually mostly do JavaScript programming, which is why I have a lot of fun contributing to the ClojureScript compiler, because I can use my sort of 8 years of professional JavaScript knowledge in implementing ClojureScript. So I could talk a lot about things like Dart, TypeScript, CoffeeScript, ASM.js, these various languages that transpile to JavaScript. I think a lot of people are skeptical of these things, and I think there's a really good reason, because a lot of these transpile to JavaScript languages don't actually present a future that's any different for what we've been doing for the past 20 years, right? Why should I use TypeScript? I know what programming in Java is like. I can make a mess, right? These languages aren't ambitious enough. So hopefully, when you see this talk, you can see that ClojureScript actually is trying to do something quite different from what these other languages are trying to do. It's very much against the status quo. So just to give some review, so ClojureScript is 1 week away from being 2 years old. We have almost 2,000 watchers on GitHub. We actually have greater than 50 contributors. That means people who actually submitted patches. And I was happy to find out that the ClojureScript build tool is the second most popular Leiningen plugin. If you've never heard of Leiningen, it's very much like the Node package manager. So that's pretty neat. So we've got a lot of traction in the Clojure community, and not much traction anywhere else because you kind of have to buy into Clojure. And so my talk isn't really to convince you to use Clojure or ClojureScript, but it's sort of show you that compiling to JavaScript can actually be incredibly interesting, especially if your semantics are really different from JavaScript or Java or Python or Ruby or whatever, which Clojure and ClojureScript try to really move to the next thing. So it's impossible for me in a short amount of time to really describe every interesting thing about Clojure or ClojureScript. So I'm going to sort of demonstrate by showing a sort of simple but somewhat trivial application running in the browser, and hopefully this can give you a taste. And I'll sort of compare JavaScript to ClojureScript. So a little study. This study is going to sort of focus on the fact that I kind of want to have a better API for manipulating CSS style declaration objects in the browser and manipulating different representations of colors. So let's get started here. So let me make sure this is still working. So down here is a REPL, and up there is the source file. I'm doing this in Emacs, but of course, if you want to use Sublime Text or Eclipse or Vim or whatever, what have you, you can set that up. But I'm going to demo in Emacs. So I'm evaluating here in the REPL, but it's actually getting evaluated in Chrome. So I'm actually compiling JavaScript on the fly and sending it to Chrome, and Chrome is sending me the result. Just to show you that this is actually true. So you can see if I pass a function into the REPL, it gets compiled into JavaScript, which looks pretty much like what you would expect, and it comes back. Okay, so what's going on here? ClojureScript actually has real namespaces, so we don't have this problem that JavaScript has where you have all these ridiculous competing module systems, right? ClojureScript has a module system. It's a part of the language specification. So here, it's just standard. I can import libraries and symbols and do all this stuff, and it's a part of the language. Everybody follows this idiom because, again, it's provided for. So I'm going to talk about some things which may seem too basic at the beginning, but I'm going to quickly ramp up. So don't worry, we'll get to the good stuff soon. So I'm going to show some differences. So this is important to illustrate that we don't really care about JavaScript semantics. For example, in ClojureScript, 0 is not a falsy value. It will never be a falsy value in ClojureScript. The empty string is not a falsy value, right? So we have a very different notion of truth. We want to eliminate these corner cases that cause, subtle bugs in our code. There are only two false values in Clojure or ClojureScript, and that's false and nil. The other thing that we have is real lexical scoping. So JavaScript scope is a very complicated topic because Brendan Eich had to do it in 10 days. So there's variable hoisting in JavaScript, and this is even an expert doesn't really understand what's going to happen. So that is not the case for ClojureScript. So here's a very common example. I can't explain every little bit, but what I have is a loop. I'm creating a function. I'm storing it in an array. This is a common mistake in JavaScript, to have a loop, construct a function, refer to the iterator variable, and then execute those functions later. All those functions are going to return the last value of the loop variable. So if you've ever done async code in a loop, you'll often see very surprising results. But in ClojureScript, that doesn't happen. Our compiler is smart enough to see that you've referred to the iterator variable in the Clojure that we're creating, and we make sure to capture the actual value for that variable. So proper lexical scoping. Something that's bigger, one thing that I love about JavaScript, I still do a lot of JavaScript. The cool thing about JavaScript when I really got it was that JavaScript has this really beautiful, simple associative model. Pretty much everything in JavaScript is an object. You can interact with objects. I mean, you can add properties to pretty much everything. Access is pretty uniform. This is quite nice. It's somewhat sullied by the fact that JavaScript has pervasive mutability, and we often have to code in a very defensive way. So ClojureScript also has this nice, simple associative model. But in ClojureScript, everything is immutable, right? Everything is immutable. And you say, well, how can you write interesting programs that way? Well, JavaScript also has immutable values. You have a number 1, you add 2, and you get 3. You're not changing 1, you're not changing 2, you're not changing 3. JavaScript also has immutable strings, right? Strings are immutable. I have string A, string B, concatenate, new string, right? This is great. It facilitates your ability to reason about the software. So this applies to ClojureScript collections, right? ClojureScript collections can also be treated as values the same way that strings and numbers are. So here I have a locally bound X that's bound to a hash map, which has a key foo and a string bar in it. Here I can associate a new key value pair, and I print that out, and then I print out the value of X. And you see that X is not changed, right? This is fairly standard fare in ClojureScript. And what's cool about this is if you've done any MVC programming for a medium-sized to large application, Backbone, Angular, it doesn't really matter. You often, if you're going to give somebody a model, right, you have to say in your docstring, don't mutate this. This is directly out of the collection, right? Or you have to defensively clone. This pervades any software that has mutability. People do this in Java, Objective-C. It really sucks, right? Do I know that what I'm getting is modifiable? This is not, nobody thinks about this when they're programming in ClojureScript. It's not an issue. Once you sort of think about collections as values and stop thinking of them as mutable containers, you're sort of freed up to think really about things, really think about, for example, equality. So here I have two hash maps, right? Notice that they're actually the same. I've defined the key values in a different order, but they're the exact same thing. This would not work in JavaScript. By default, equality is deep, right? We do provide the memory check to see if two things are the same if you want to do this for efficiency, but nobody uses this because almost every time you want to know if the data structures are the same, the values are the same. You don't care if they represent the same thing in memory. I can't tell you how many JavaScript apps I've written where I wanted default equality, the default equality check to be deep. So deep equality by default. The other thing to note is that in ClojureScript you have real collections. We often hack around JSON, and it's actually pretty not nice. But we have more collections in ClojureScript. For example, we have an immutable vector, which is like a JavaScript array. There's a polymorphic function called conj, which says it can take any collection and do the sensible addition to that collection. For example, for the vector type, we get a new vector with 4 appended to it. It's like array push. We have real sets. We don't hack around arrays the way a lot of JavaScript libraries do. These are real sets. So here I have cat, bird, dog in this set, and if I add bird to it, I should get back a set unchanged, right? The set already has that element in it. If I add zebra to it, zebra, yeah, that should get added, right? That's a new thing to that set. If you're familiar with Objective-C, Smalltalk, or Java, something that's really cool in those languages is that they support arbitrary keys. So ClojureScript also supports arbitrary keys. JSON limits you to strings. So you can use any data structure and use it as a key. Here I have a map where I have a vector 1, 2. That's the key, and I have a value, and I'm saying, hey, I got a complex key. I can write, get out of that map the value for the key 1, 2. Complex keys, they just work. And this is actually super efficient. So we've spent the past 2 years optimizing all this stuff. These things perform extremely well enough to write, interesting software with. So a big departure from Lisp or even JavaScript is that, ClojureScript is sort of constructed around what's called protocols. If those of you that are familiar with Go has Go, there's a thing called Go interfaces. Java has interfaces. It's similar also to Haskell's type classes. So collections can implement a protocol. And what's nice about this is that we can have uniform iteration over all collection types. Not only the collection types that we ship, but all future collection types. You can make your own collection, you can implement the protocol, and you can just plug it into any code, right? This is like serious code reuse. So I can ask a hash map for the first key value pair. I can get the first item out of a vector, first item out of a linked list, first item out of a set. So in JavaScript, you have to do 2 kinds of iteration for objects and arrays. I think they're going to solve this in future versions of JavaScript, but it's not something you can use today. And ClojureScript ships with uniform iteration, since day one. Something I don't have time to talk about, which is pretty cool, is that ClojureScript also supports lazy sequences. If you're familiar with Haskell, Haskell is pervasively lazy. Clojure is mostly strict, but we have lazy sequences. And this is because JavaScript doesn't support tail call optimization, right? You can't actually write recursive functions in JavaScript because it doesn't optimize them. You're going to blow the stack. So Clojure gets around this by implementing lazy sequences so that you can have recursive functions that don't blow the stack. For example, right here, I'm constructing an infinite sequence of the word web, an infinite sequence of the word rebels. Like it's just going to, like sequences of where these words just repeat. I interleave two infinite sequences, and then I extract out the first 100 values of that infinite sequence. And there's tons of amazing tricks you can play with lazy sequences. I don't really have time to show those to you. But hopefully this gives you a taste of the basic differences between what JavaScript and ClojureScript allows. So let's look at another bit. So going back to protocols, so you really can't get deeper than functions in JavaScript. Once you get to functions in JavaScript, there's nothing lower level than that. And this isn't true for ClojureScript. One of the protocols is things that act like functions. So imagine for some crazy reason I say, I want regular expressions to be functions. I actually want to be able to use regular expressions in every place that I would use a function. So here I'm actually extending JavaScript regular expressions to act like functions. So when I invoke a regular expression as a function, it'll take a string s, and then I call the standard library for taking a regex and matching it with a string, which will return nil or a possible match. Magically, I can now filter lists of strings using the regex, right, as a function. And there's no more work to do. 4 lines of code, I now have regular expressions that can be invoked as functions. And of course, I can combine this in endless numbers of ways because they're now functions. Okay. So let's get to, again, the trivial example, talking about colors in CSS. So here, I'm going to make a new definition in this namespace. I'm going to get something by ID, and there's this red box on this page. I now have a reference to that div on the page. So here you can see some interop, like, you know, if you're going to target JavaScript, you better have decent interop, and we provide decent interop. So I just want to show, what does this keyword to property function do? This keyword arrow property. I'm going to write keyword to property and then background color like this. And I get a CSS, like, you know, property, right? I rewrite the ClojureScript keyword into something that can access a property in JavaScript. And then this is one little function I want to break down. What does it do? It takes a ClojureScript keyword, it converts it into a string, it drops the first semicolon, and it splits it on dashes. And then what it does is we destructuring assignment, we pull apart the head and the rest of the parts. This is also an ECMAScript 6 feature, right? ECMAScript 6 has destructuring assignment. So we already have that, and ours is more generic because in ECMAScript 6, right, it only works for objects and it only works for arrays. In ClojureScript, it works for any sequence, right? I showed you the fact that we have uniform iteration. So this works for every collection type. We can destructure it as a sequence, and that's pretty neat. Okay, so I'm going to have to move pretty quickly here. I want to be able to extract the styles, the CSS styles declaration from this element. So if I go styles, box, I get this opaque object, which is the CSS styles declaration object. And what I want to do is I want to be able to treat that thing as a function. And so this code here allows me to do that. Use it both as a function and also do lookup. And we'll see what that means. I can go styles, box. And because this is Lisp, anything in the first place of a list is a function call. So I can say styles box width. The styles box height. Right? And this works this way too because keywords themselves are also functions. They can also act as functions. Because this is a functional programming language, we can do combinations. For example, there's a function called juxt. We can juxtapose any two functions, and this is all I need to get the dimensions, the width and height together, right? So you've seen hardly any code, right? And I'm doing as much stuff as jQuery does in thousands of lines of code because ClojureScript is constructed on like lots of composable abstractions. Okay. So the other thing that ClojureScript does, we have something called, I just want to demonstrate the parseInt because ClojureScript has real multi-arity functions. We never touch the arguments object because that's actually a pretty big performance hit, and ClojureScript relies on multi-arity functions everywhere. So we actually have, again, real multi-arity functions, and we're able to dispatch on arity very efficiently. And that's also kind of cool. So here's the meat of the matter. I'm writing a library, and I want to be able to manipulate colors, and I want to have different representations. Maybe I'm looking at a CSS string. Maybe I have a JavaScript array. Maybe I have a vector. I want to be able to deal with the components of in a uniform way, regardless of whatever data type I have in hand. So here's the abstract protocol, and then I can make it work for vectors. Here I can use destructuring assignment once again, right? This will take a 4-element vector, extract the red component, return it. This will take the green component, return it, blue, and so on. So if I go red, 255, 150, 15, right, that should be like that, so on. Then I want this to work for strings. I don't have time to break apart this code. But here we can see I extend all JavaScript strings to work with this protocol. So I can go red, RGB, this is a CSS rule, right? A CSS style for defining colors. Right? So this just works. Within this module, I can take any representation and extract colors out of it. And so here, we have the familiar map operation. I now have this function which can handle any different representation, whether it's a vector, it's a native JavaScript array, or a string, I can extract the green components. Right? Again, we haven't looked at very much code, and I'm able to do quite a bit. The types of things that you want to do when you're programming, doing client-side web programming. Okay. So that's all cool. Definitely it's true that you could do this stuff in JavaScript, but maybe it will require more code. You could do this in Dart. Maybe it'll require more code. You could do it in TypeScript. Maybe it'll require more code. But really, are we really getting that much? It's nice that it's extensible, but what is this really buying us in the future? So I want to demonstrate some stuff that's actually really difficult to do if you're not a Lisp. So Clojure is quite different from traditional Lisp. It's very different from Scheme or Common Lisp, but there are aspects of it that it shares with those languages that are really powerful, especially if you want to do DSLs. So if you've ever seen me talk at a conference, I'm really big on logic programming. Boodle referred to this with Oleg Kyselyev. So this book is called The Reason Schemer. It's by Dan Friedman, who wrote a very beautiful book called The Little Schemer, which I thoroughly recommend. His ex-PhD student, and Oleg Kyselyev, who's very well known in the functional programming community. So they show you how to embed Prolog inside of Scheme in 200 lines of code, right? Most of Prolog embedded directly into Scheme. And this is really, really, really cool. So I saw this book, my mind was completely blown, and I was like, I want to make this work in Clojure, which is more popular than Scheme or Common Lisp. And so I did this. Last year I got invited to JSConf 2012, and I was like, I wonder how hard it would be to port this logic programming library to ClojureScript. And so I did this. So I want to show this DSL running using the classic Prolog example of genealogy, just because it's pretty easy to understand. Okay, so I'm going to load this file. So again, we have this namespace declaration, and we're loading in macros, which are going to do lots of crazy code transformation and fun stuff. And then here we get to the meat of the program. So it took a second to load down here. Let's switch into this namespace. So this is running against Node.js. So previously I was evaluating everything inside of Google Chrome. Now I'm evaluating everything inside of Node.js. And just to show you this is true, I'm going to load the file system module. Node.js code. Okay. So I can do what I would do in Prolog. I can just declare a bunch of facts. And this is a child relation. I want to know if X is the child of Y. I state a bunch of facts, kind of like how you would do in a database. You store a bunch of facts. Robert is the child of John. Martha is the child of John. Robert's the child of Mary. Martha's the child of Mary. And so on. And this is, as you can see, really declarative. I mean, there's not much in the way of conditional logic going on here explicitly. So you're going to see a lot of code get generated, which I'll talk about in a second. I define some facts about who are male, who are female. And then once I have these facts, I can start doing the types of things you'd want to do with SQL or like with a database. Now I can describe the relation for son. Somebody is a son, some X is a son of Y if X is male and X is a child of Y. Same thing for daughter, right? X must be female and X must be a child of Y. Where it gets interesting is something like grandchild. So we actually have a graph traversal going on here, right? Some X is a grandchild of Y if there's some person Z where X is a child of Z and Z is a child of Y, right? It's one step removed. So this is graph traversal, and that's how we know if X is a grandchild of Y. And I've got a bunch of others, but I'm going to sort of evaluate these real quickly. And then down here, I can start running queries. So I can ask, who are John's children? And I get back Robert and Martha. I get who are John's daughters? I get back Martha. Who are Robert's grandparents? I get back all the grandparents. So this is traversing the graph to figure this out. And I'm not, again, you haven't seen an if, you haven't seen an else, you've seen nothing. You've seen no actual logic, right? I just made declarative statements. Who's Robert's grandmother? And I get back the list. So this is really powerful. This is a DSL, and this is possible because we have macros. So that's cool, but let's see something non-trivial. The genealogy example is very simple graph traversal. I want to show a more interesting constraint-solving problem. So on December 17th, 1962, Time magazine put out this really cool puzzle. It was called A Puzzle for the Logical. It's often referred to as Einstein's puzzle or the zebra puzzle. And Peter Norvig of Google wrote a really fantastic book in the 90s called The Paradigms of Artificial Intelligence Programming. This book alone is worth learning Common Lisp. This is one of the best programming books I've read. It's incredible. In this book, he shows you how to build Prolog in Common Lisp. You build an interpreter, then you build an optimizing compiler, and then he shows once you have that, you can solve this problem. It's trivial, right? You can literally write down each statement of the puzzle, run the puzzle, and you'll get the answer. So the way that the puzzle works is that you have 5 houses, right? Each house has 5 properties. What's the nationality of the person that lives there? What type of pet do they have? What do they like to drink? What do they like to smoke? What color is their house? And in what position are they to their neighbor? And he points out if you brute force search this entire space, there are 24 billion solutions, right? And he shows that by building Prolog, you can make this tractable. You don't have to look at all those possibilities. And in 1993 on a Pentium 3 computer, he could solve this problem in 17 seconds, which seemed pretty impressive. So I'm going to show you how fast we can do it on a 1.7 gigahertz MacBook Air in 2013. So before we do that, I just want to show what the code looks like for this. So again, it's all declarative. Here I have the first statement, which says there's 5 houses. The underscores represent the house, and there's 5 properties in each one. The middle house is where the person that drinks milk lives. First house is where the Norwegian lives. Next to the Norwegian is the blue house. To the right of the ivory house is the green house. Englishman lives in the red house. Again, I'm just translating the sentences of the puzzle directly into code. So I'm going to run this against a recent build of V8. Oops. So after V8 has had time to warm up, we get running times as low as 16 milliseconds to solve this puzzle. So this is 1,000 times faster than Peter Norvig could solve it. And this is running on JavaScript, right? The answer to the puzzle, which is the final question, was who drinks water and who owns a zebra? We can see up here, because the middle component of each list of properties is the drink. The Norwegian drinks water, and the Japanese person owns a zebra, right? Because that's where the blanks are. Okay, so that's pretty interesting. I think this sort of illustrates that, as Reg alluded to in his keynote yesterday, is that we basically have supercomputers now, right? Even the crappiest computer is a supercomputer, yet we program as if we have Apple IIs. It's really crazy. And I think we should be thinking a lot more ambitious about the way that we write computer programs, given the realities of how sophisticated our hardware is now. So that's a cool demo, but how much code does it generate? Because you saw me evaluating and it's like, wow, tons of code's coming out. And then it's true that if you don't do anything fancy, we generate that logic file, just that logic module generates 940K of JavaScript. And at which point you'd probably just like, okay, really cool demo, but we're never going to use this, right? So one thing that we do is we spend a lot of time making sure that the Clojure code that we generate is optimizable by the Google Clojure compiler, which is a popular JavaScript compression tool. Most JavaScript libraries can't take advantage of what it does, though, right? Because you don't want to write in this horrible style that the Google Clojure compiler dictates. So this horrible style, we generate that for you. So you can write in a very clean style, but we make it conform to the Google Clojure compiler standard so that when you run advanced compilation, it's actually 79K. That's a 10x reduction for this library. And of course, after gzipping, I can ship to clients in 21K a full prologue, right? That's pretty insane. But of course, not everything is awesome. People often talk about how awesome their stuff is, and really, ClojureScript has lots of issues. Definitely a wimpy REPL. I mean, it's still very weak. It takes a long time to start up. I mean, there are lots of things we could do to improve it, but nobody's actually done that work. Whole program optimization, of course, means that there's no dynamic code loading. That may be a problem for some applications. We still have no source map support, so we're behind CoffeeScript, TypeScript, Dart. They all have good source map support. I've done a lot of work on that, and so that's in progress, hopefully soon. So in general, the tooling support is not that great. I often, when people say, should I learn ClojureScript first? I'm like, I wouldn't do that quite yet. But hopefully this has demonstrated that it is a pretty interesting piece of technology. So I'm going to end with a little bit of a rant. But before I start my rant, this sort of illustrates that ClojureScript is doing pretty well on the power. I mean, hopefully I've showed that it's kind of a powerful language. And it does pretty well on the complexity side as well. So everything that I've shown you is about 12,000 lines of code. The compiler is less than 5,000 lines of code, and the standard library is about 8,000. And because the standard library is so big, I mean, that's definitely why we really need Google Clojure to help us make that smaller. But the whole system is only 12,000 lines of code, which I think is pretty cool for how much it does. So my rant. So I think Steve Jobs has been a sort of inspiration to a lot of people in computing. He really has, I think, changed the face of computing many times. He got kicked out of Apple in the early 80s. He sort of was like, well, I really love computers. I still want to do this. And so he decided to start this company called Next. If you're using OS 10, you're using Next. This is a very interesting company. He focused on education. He went to universities all around the world looking for the smartest, brightest people to help him build this machine. One of these people that he hired, who you've probably never heard of, is Jean-Marie Hulot. He invented Interface Builder in 1984, right? So the Interface Builder that you use today is basically the system that he built in 1984 on a Mac using Lisp, right? So something that changed when Steve Jobs hired him, like they were like, well, nobody knows Lisp. We're gonna switch to C, Objective-C, because everybody knows that. And it's kind of sad because this kind of goes back to what Reg was talking about languages and tooling, right? When Jean-Marie Hulot originally designed the system, you had all the fancy outlets, you could make your stuff graphically, but when you ran your program, at any point while it was running, you could look at the source code, modify it, update the code while the application was running, never stop it, right? So this is a very much more, I think, powerful feedback loop than the type of interaction we have with software development today. Still, even given the fact that the development cycle kind of sucks for Xcode, still that model, the interface builder model, was still powerful enough, and that came from Lisp, to allow applications like Mathematica. The first version of Mathematica was on a Next machine. Doom was first developed on a Next machine. John Carmack's Doom. What's sad, though, is that, Jean-Marie Hulot came up with these ideas. That's 30 years ago now, right? 30 years ago. And Apple, I think, has done a pretty poor job of really improving on the original ideas. And in fact, to me, Xcode is sort of a step backwards. It's a very similar story to Smalltalk. Smalltalk was also this kind of beautiful environment where the language and the tooling were at about the same level. Visual Age, which made a commercial Smalltalk, did Visual Age for Smalltalk, then they did Visual Age for Java, which became Eclipse. Right? So you see the same progression from an extremely powerful system where the language and the tooling are really in harmony to a sort of shitty language that's at odds with the tooling. So I hope what I've demonstrated here is that I actually really believe in web technologies. I think the IDEs are kind of dead. They're sort of controlled by, sort of far too enterprisey corporate interests. I think that's also true for browsers to some degree, but at least there's very serious competition, right? We have a nice sort of virtuous thing happening because everybody wants to have the best browser. And so as developers, we benefit. And hopefully what I've demonstrated in this talk is that I think the future is very bright. I think we shouldn't be afraid of compiling to JavaScript, especially if we're delivering more value than the current crop of languages give us. That was it.
Hi. I'm wondering, is it possible to write a test for ClojureScript? And second question, can you use ClojureScript with UI component, like UI components?
So the first question, yes, there's a testing framework and library for ClojureScript that people use. The answer to the second question is you can use the Google Clojure UI components, which I don't like at all. And people are slowly starting to work on custom UI components which integrate better with Clojure semantics. But yeah, you can use existing things or build your own. Does that answer your question? All right.
Can I write code in ClojureScript and then make it a library and then call it from JavaScript? Or do I have to jump through?
No. So Google Clojure compiler, we hook into a lot of features it has, so you can export a symbol, right? And then you can provide an interface that JavaScript can call into. Actually, related to that question, so the persistent data structures I think are really cool, especially if you use Node. So I've packaged up just the persistent data structures. It's actually a Node module. It's called Mori. You can install it right now. Again, if people have feedback on the API, I'm all ears. I really want the persistent data structures to be easily usable from Node.
Yeah, so I was wondering if you can run your programs backwards using your logic implementation?
You can run programs backwards, yes.
Excellent.
Could you demonstrate a coin, perhaps?
Not in ClojureScript. We don't have that yet.
Sorry, I'm going to run around this for the next one.
So I'm always reading these highfalutin blogger guys and their lack of oxygen at their high altitudes, and they always say that one of the benefits of learning these advanced languages is that it makes you better even when you're programming with something where perhaps you're at work and you're not allowed to just use ClojureScript just because. Now, I have not used ClojureScript, so can you give an opinion, just a personal opinion, if someone were to learn ClojureScript weekends, nights, for their own edification, how would that just make them hate working with normal JavaScript or CoffeeScript? Can you expect to have some new insights or be better? Can you just give your personal opinion on what that would be like?
So I actually I work at the New York Times. I program in JavaScript. I don't hate JavaScript. I write JavaScript every day. I like it. I've actually done projects in CoffeeScript. A lot of people on my team hate me for doing that, but I enjoy it. For me, languages are about learning something new. It's about advancing. Like for me, the keynote today was like, I don't want to be scraping ornaments. Okay, this is not what my profession as a programmer should be. Right? I believe programming is an art. And really, if we're not advancing ourselves, our connection to this kind of amazing thing called computing, then I'd rather do something else. So I think, no, I don't think you'll hate JavaScript if you get into this stuff, or hate CoffeeScript. I think, in fact, you become more forgiving of languages of fallibilities,
So I've been watching all the Brett Victor talks recently, and I feel like what he's trying to do is make editors go away also. He wants to get rid of Xcode, he wants to get rid of Eclipse, and he wants people to or an ecosystem of really interesting editors and experiences of editing code pop up. But I haven't seen any parallels between the kind of stuff that you and Reg are talking about and the stuff that he's talking about. Do you see the two goals of like the interface and how people think about code and visual representation of code? Are those aligned with more functional ideals and like a revival of Lisp and all of that?
So I think that's an even bigger discussion, right? Because what I tried to demonstrate that like language is cool, tooling really sucks, right? The tooling thing needs to be solved. I really was heavily inspired by Reg's keynote on the first day, right? We all program in JavaScript, but how many of you actually said, oh, ES code gen, S prima, I could parse my JavaScript and run some basic sanity checks, right? We have these amazing tools and nobody's doing anything with it. Why don't I put it into MongoDB? Why don't I put the AST into MongoDB and start running queries? This is like, you have all the tools, but as programmers, I think we always think of languages as sort of a black box that you can't like poke inside. And I love this conference because you're watching people do incredible amounts of hacking. And I really think that languages should be subject to the same amount of hacking that we do on OpenGL or on Content Editable, right? We really shouldn't think about languages being in this like higher plane where we can't mess with the way they work. So I really think that people should explore this. I think what Brett Victor wants to do and what languages are trying to do are very well aligned.
Last chance. Okay. Oh, I just have to say, I thought your node repl was really awesome.
Oh, yes. That wasn't, did I say it was mine? It was yours.
Well, I kind of wrote it. Anyway, unless there are further... is there a question? No, that's the phone. So who gets the phone?
I thought Max's question was quite good.
Yeah, he needs a phone to go with that awesome bed.